Engineers. All the candidates who joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can start with the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session. The ideal duration for today's session is going to be approximately 45 minutes, and the agenda for today's session is going to be, we are going to discuss some of the important questions, and with the help of those questions, we will try to understand some important concepts related to your subject, electrical machines, and specifically we are dealing with synchronous machines. Already we have completed the first part of synchronous machine yesterday 6 p.m. in the evening. If you have missed that session, you can attend that session after completing this session. And today we are going to take the second part. Today we will be discussing some good quality questions related to your subject, electrical machines or synchronous machines. So let us start our discussion. Some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from ITBHU in 2010. I have written a couple of books, and my areas of expertise are power system, electrical machines, electromagnetic field theory, material science, engineering ethics, and current affairs. Before we start the session, a very important information for all those candidates who want to prepare for GATE 2023. We are going to have 5 months to go for the GATE 2023 examination, and you have got ACE GATE 2023 with free GATE Achiever series, which is available on BYJU'S Exam Prep app. And to attend these sessions, you have to register yourself here. Okay, so you just go to the BYJU'S Exam Prep app. You will see the pop-up link notification. Follow that, follow the simple procedure, and you will be able to attend these live classes. Yes, Vishwanathan, Pranjal, how are you? Welcome to the session. Next, all the candidates who are already in a job, who are a working professional, or those candidates who are in their college, whatever year you may belong to, how to find time to prepare for GATE 2023. So one of the most reputed faculty for instrumentation, Faheen sir, he is going to conduct a workshop, that is how to ace GATE with college and job. It is going to be conducted on 27th of September, and the timing is going to be 8 p.m. If you want to attend this workshop, then you have to register yourself on the BYJU'S Exam Prep app, because this workshop is going to be conducted on the BYJU'S Exam Prep app. So let us start with the first question. I hope you all are ready. Everybody just quickly hit the like button, like, share and subscribe. Everybody just quickly hit the like button, share it with your friends and colleagues so that more and more people are going to be joining with us. And subscribe to BYJU'S Exam Prep if you have not subscribed till now. Let us try to understand the question. He is saying there is a 20 MVA 3-phase star connected alternator with the armature resistance 0.5 ohms and the synchronous reactance of 5 ohms. So you can write the synchronous impedance as 0.5 plus J5 ohms. He is saying it is operating in parallel with a constant voltage bus bar of 11 kilovolts. So you can say the terminal voltage or the bus bar voltage is going to be 11 kilovolt. He is saying if the field current is adjusted to give the excitation of 12 kilovolts, then what is going to be the correct answer? So you can understand the field excitation magnitude is basically going to be 12 kilovolts. Now, just by observing the options given, you can very easily understand that this question belongs to the MSQ category, multiple select questions. You all must be aware that very recently GATE examination has introduced one new category of questions, that is multiple select questions, in which 2 or more than 2 options can be correct. And if you read the options carefully, because in 2 of the options he is asking about the maximum output, and rest 2 of the options he is asking about the power factor. So definitely this question is going to be multiple select question type. Let us try to understand how we are going to proceed for this particular question. In the options, he is basically talking about 2 things. Number 1 is what is the maximum output, and then he is talking about what is the power factor. Now you please try to understand, your synchronous generator is going to be something like this. If I draw it per phase basis, then you can understand This is going to be the terminal voltage. Suppose it is the bus bar voltage. This is going to be your excitation EMF. And this is going to be your synchronous impedance. This is synchronous resistance and this is synchronous reactance. Now, if I want to write the armature current, how I will be writing the armature current? Can you tell me? You can write the armature current as EF angle del minus V angle 0. Suppose we are taking the voltage bus bar as the reference voltage. So, this is going to be angle 0 degree divided by ZS angle theta S. How we are defining this ZS angle theta S? You can understand from this synchronous impedance, you can find mod ZS. It is going to be under root 0.5 square plus 5 square. And what is going to be theta S? That is the angle impedance of the synchronous impedance. Okay. What is the angle impedance? You can understand. It is going to be tan inverse 5 upon 0.5 that you can find. Now, if you see this equation, there is only one unknown that you have to find. In order to find the armature current, you know what is the excitation EMF, because he is saying the field current is adjusted to give the excitation of 12 kilovolts. So, you have the magnitude of the excitation EMF. Bus bar voltage, terminal voltage EMF is also mentioned, magnitude is mentioned, and phase you have taken as the reference phasor. ZS magnitude and angle both are given, so no problem with that. The only thing is how to find this. Now, let us try to read the question again and understand the options given. You will see in two of the options he is talking about the maximum output condition. How we are defining the maximum output condition? The general expression for writing the power delivered by the generator to the bus bar or the infinite bus is going to be what? It is going to be mod EF mod V upon, you can write mod ZS, and this is going to be cos beta minus del, or it is better if you write in terms of ABCD parameters right now, because I will give you the simplifications, minus mod A upon mod B. This is mod V square cos beta minus alpha, where this B parameter, ABCD parameter, B stands for magnitude B, angle is beta, and A parameter stands for magnitude A and angle is alpha. Now, for this power delivered to the infinite bus, if it has to be the maximum power, then what is the condition for this? The condition for this maximum power is that this value has to be the maximum one. What is the maximum value of cos beta minus del? The maximum value of any sinusoidal quantity is 1. When it is going to be 1? When del is going to be equal to beta. When del is going to be equal to beta. Now, what is beta? Beta is nothing but theta S, or you can say it is, already we have found, it is tan inverse 5 upon 0.5. Is it clear for everyone? Are you able to follow this? Just tell me yes or no. Yes, Vishwanathan, what you are getting as 84? Are you talking about beta? As per my reference, I don't have the reference for beta. Yes, I have. It is 84.26. It is 84.26. You can write it here. Here, ZS magnitude is going to be 5 and theta S is going to be, just confirm this value, it is 84.26. 84.26 degrees. So, if you know the angle theta S, because del you are going to replace, now you are going to write the armature current as EF angle theta S minus V angle 0 degree divided by ZS angle theta S. Put the value, EF is going to be 12 kilovolt, but you have to understand you are writing it on per phase basis. So, you have to rationalize it from line voltage to the phase voltage. Vishwanathan is asking, sir, current is, see, that MVA is given as the rating of the machine. Okay, that will give you the current only in case of full load conditions. Are you getting this or not? Yes or no? So depending upon the terminal voltage, you have to decide what is the current going through the generator to the bus bar. Directly you cannot write like that, otherwise it is going to be fundamentally wrong. Angle you have just found, it is going to be 84.26 minus, it is going to be 11 kilovolt, angle 0 degree divided by ZS is given as 5, angle is 84.26 degrees. Just find this, value. As per my reference, you must be getting the current as 1783.6 and angle you will be getting as 45.12 degrees amperes. Is it clear, everybody? You got the current magnitude and you got the phase angle for the armature current, and this is going to be with respect to the bus bar voltage, this terminal voltage, yes or no? So what is going to be power factor? What is going to be operating power factor? Can you tell me? It is going to be cos of, what is this angle? 45.12. This is going to be 45.12. If you solve this, you will be getting it 0.7056, and this is leading, because this current is leading the terminal bus bar voltage. Why delta is 0? Which delta is 0, my friend? Where I have said that delta is 0? I am saying del is equal to beta. It's not delta. EMF angle is not 0, my friend. EMF angle is not 0. It is theta s. It is theta s. It is the impedance angle of the synchronous impedance. Let me just brief you again. This is the power which is supplied by the generator to the infinite bus. He is asking about the maximum output condition. For the maximum output condition, if you want to get the maximum power output, what you have to do, because this portion of the equation is going to be constant. These are the line parameters, ABCD parameters, A and B you cannot change. Voltage you are not changing, bus bar voltage. Beta is the angle of B parameter, that also you cannot change. Alpha is the angle of A parameter, that also you cannot change. So this part you cannot change. Only you can vary this part. Excitation you have already changed, so you are putting the new value. Voltage magnitude cannot change, B cannot change, so you can only do the variation in cos beta minus del. What is the maximum value of cos beta minus del? That is 1. When cos beta minus del will be 1? When del is equal to beta. When del is equal to beta. So while writing this expression for the current, I am replacing this del value with theta s because I am putting the maximum output condition. I hope you are getting this. Is it clear, everybody? So if you see the options, option C is going to be the correct option, but there can be more correct options. So this is going to be wrong because one of C and D has to be correct and one has to be wrong. Now for A and B options, he is asking about what is this maximum output? What is going to be the maximum output? Let's try to understand. The maximum output you can directly write in terms of the terminal voltage and the armature current as root 3 VIA, and this is going to be cos phi. So this is root 3, 11 kilovolts. Current value is 1783.6. And what is cos phi value? 0.7056. If you solve this, you will be getting 23.98 megawatts. 23.98 megawatts. Is it clear, everybody? Are you able to follow this? If you have any doubt, you can ask me. Is it clear? Just tell me yes or no. Yes, everyone. All the candidates who are live with me. I hope this is clear. Let us see the next question. Little bit similar question, some new concept you are getting. A star connected 11 kilovolt turbo generator with synchronous impedance of 1 plus j 10 ohms per phase. So Zs is given as 1 plus j 10 ohms per phase. Again, what is the magnitude of Zs? Under root 1 plus 100, that is 10 square. You can find it. And what is theta s? It is tan inverse 10 upon 1. This also you can find. Let me just give you these reference values. You can cross check it. Okay, so I don't have the reference values. Okay, so you just find it and tell me what is the value you are getting. Now next he is saying is connected to the infinite bus at the rated voltage. He is saying the alternator delivers an armature current of 100 ampere at unity power factor to the bus bar. Okay, this is the first case. Now he is saying, now the alternator output remaining constant. Alternator output remaining constant means what? P is going to be constant. The real power transferred to the infinite bus is going to be constant. Vishwanathan is saying 10.04. Everybody please cross check this value. 10.04. And what is the angle? The angle is 84.24. Please cross check this value, 84.24 degrees. He is saying the alternator excitation is increased by 15%. It means what? EF2 is going to be 1.15 EF1 because 15% excitation has been increased. Again, by looking on the options, you can very easily understand in two of the options he is talking about load angle and rest two of the options he is talking about power factor. So definitely this question is also going to be multiple select question type. See, I can just suggest you, because nobody can predict anything, that for next year GATE examination, you may expect MSQ questions from GATE electrical, because last 2 years, there were no questions from GATE electrical from MSQ. So this year you may get a surprise. This year you may get a surprise. Is it clear? Now let us see. If you talk about the power delivered by the generator to the infinite bus, this is going to be mod EF upon mod V upon mod B, and this is cos beta minus del minus mod A upon mod B. This is mod V square, and this is cos beta minus alpha. Now suppose you take a short transmission line approximation. If you take the short transmission line approximation, what are going to be ABCD parameters? Can you tell me? The ABCD parameters are going to be then 1, Z, 0, 1. Yes or no? For this approximation, if you go, because it is going to be very complex if you don't go for this approximation, then this mod B is simply going to be mod Zs. What is going to be beta? Beta is simply going to be theta s. What is going to be A magnitude? That is going to be 1. What is going to be alpha? Alpha is going to be what? Alpha is going to be 0. Okay. Now this cos beta minus alpha, we are assuming it to be 0. Why? Because beta is going to be the impedance angle of the synchronous generator, which is going to be very close to 90 degree. You just have found the value. It is 84 point something, and alpha is going to be a 0 value. So cos 90 is 0. So any value which is close to 90 is going to be very close to 0. So we are ignoring this term and we are focusing only on this part of the equation. So I can write mod EF mod V mod Zs, and this is cos theta s minus del. He is saying this power output is constant. So out of this equation, if this is constant, the only variation is in this and this. So can I write mod EF2 cos theta s minus del 2 is equal to EF1 cos theta s minus del 1. This equation you have to use. Is it clear, everybody? What you have to find? You have to find the load angle. Load angle obviously for the second case. So you have to find this value. Do you have any relation for EF2 and EF1? Yes. It is given in the question. EF2 is 1.15 times EF1. Theta is value you have just found. What is del 1 value? Because you have to find the del 2 value. What is going to be del 1 value? Del 1 value very easily you can find from the statement given in the question, that is the alternator delivers an armature current of 100 ampere at unity power factor to the bus bar. So for del 1, okay, for del 1 you can write EF1 angle is del 1. It is going to be how much? This is going to be V angle 0 plus, what was the armature current? 100. Angle is, because it is unity power factor. So what unity power factor means? What? Cos phi 1. When cos phi becomes 1? When angle is 0. So it is 100 angle. It is 100 angle 0 degree. And what is the impedance? It is 1 plus j10. Just solve this. Okay. What is the V value? V value is, I think it is mentioned in the problem. It is 11 kilovolts. It is 11 kilovolts. It is 11 kilovolts. But you have to write it in terms of per phase value. So you have to write 11 kilovolts divided by under root 3. Is it clear, everybody? So my friend, if you solve this, then you will be getting EF1 angle del 1 as per my reference, it is 6527.98 and the angle is 8.81 degrees. This is the voltage. Now this 8.81 degrees is nothing but your del 1 value. And what is EF1? It is 6527.98. So what is going to be del 2 value from this equation, because del 1 also now you know. So if you calculate from this equation, you will be getting del 2. I am just giving you the reference value. It is 6.88. You will be getting del 2 as 6.88 degrees. So option A is going to be the correct one. In the previous question, there was one more correct option. Yes or no? A, 23.98 was the maximum power output, if you remember. So in case of multiple select type questions, you have to select all the correct options. Okay, if you leave it, then no marks will be awarded. But there is no negative marking for MSQ questions. And MSQ and NAT questions, there are no negative markings. Is it clear? Now in the next part, he is asking about the power factor. How you are going to find the power factor? You have to find the armature current in the second case. How you are going to find the armature current in the second case? Armature current in the second case is going to be EF2 angle del 2 minus V angle 0 degree divided by ZS angle theta s. Del 2 value you know, EF2 you know. What is EF2? 1.15 times EF1. Do you know the EF1 value? Yes. 6527.98. Just put this value. So EF2 also you can put. And if you solve this, okay, if you solve this, then you can get armature current in the second case. As per my reference, it is 141.54 and the angle is minus 45.08, minus 45.08 degrees, and this is amperes. Now from here you can find what is the power factor. So power factor is going to be cos of 45.08, 45.08, and it is going to be lagging. If you solve this, you will be getting 0.7061, and this is lagging. So what is going to be the correct option? Yes, everyone. Is it clear? Are you getting a little bit of confidence? Only one candidate is responding in the comment section. I don't know why. Just tell me yes, fast. Are you able to follow this? Only one candidate is able to respond anyways, no problem. Go to the next question. Next question is a little interesting question, but before that, in the starting part of our discussion, I have given you the information regarding the workshop that is going to be conducted on 27th of September, that is tomorrow, and the timing is 8:30. So if you want to attend that workshop, you have to get yourself registered on the BYJU'S Exam Prep app. So after this session, you can go to the BYJU'S Exam Prep app and you can get yourself registered. This workshop is basically discussing that if you are a working professional and if you are a college going student, then how you can cope up, how you can manage your GATE preparation along with your job responsibilities or with your college studies. Okay. This session is going to be conducted by one of the most reputed faculty in instrumentation, that is Fanin sir. Now let us see this question. This question belongs to the synchronizing procedure of an incoming synchronous generator with the existing system or the infinite bus. So this question, if you read properly, he is saying the sequence of darkness of lamps. Now sequence of darkness basically deals with the synchronizing procedure we are having, the lamp method. So there are different types of lamp method. In this type of lamp method, you have three lamps connected in a certain way and their brightness or darkness at different instant, and their sequence is going to give you some information. What is that information? If you talk about the sequence of darkness, it is going to be same as sequence of brightness. Yes or no? Because something which is going to bright first, there is going to be dark, become dark first also. Remember, yes or no? So the sequence of brightness and darkness, you should not get confused, it is the same thing. Now you please try to understand the sequence of darkness of the lamps is given as LA, LB, LC. It means the first lamp which is going to become dark, completely dark, is LA, then LB and then LC. Now in the options he is asking you some questions about the phase sequence and about the frequency. This is frequency. Okay, this is frequency. Okay. Now understand the first thing. If the lamps are getting dark or bright, at different instant, then the first conclusion outrightly that you can draw is that phase sequence is opposite. Okay, you can see it by the proof also if you have not read the theory, or you can simply attend the playlist. Okay, I have one complete electrical machines playlist which is available on YouTube by BYJU'S Exam Prep app, that I have covered all the major portions for your GATE examination. You can enjoy those sessions and you can complete your preparation. You can see this detailed theory part there. that if the phase sequence is going to be same, the incoming machine and the outgoing machine, the situation is something like this. Okay. Now this is the incoming generator or incoming machine. Incoming generator or machine means the generator which is now next going to be connected to the already existing system or the infinite bus. So this is going to be your infinite bus or the already existing system. Now suppose this is going to be R phase, Y phase and B phase, and this is suppose going to be R dash, Y dash and B dash. Now if the phase sequence of connection is going to be same, then all the three lamps are going to be bright or dark at the same time. Are you getting this? This is the first method. But when all the lamps are bright or dark, it is very difficult to know what is the middle of the darkness. Yes, because at the middle of the dark period, we are going to connect the switch. Are you getting this? Then we go for another method. Okay, when the lamps are going to be bright and dark at different time instant. In this method, the phase sequence of the incoming generator is going to be different or opposite to that of the phase sequence of the infinite bus. Then the lamps are going to be bright or dark at different time of instant. So one conclusion outrightly you can draw from the question, because he is giving you the sequence of darkness. Sequence of darkness means one, other, then other, next. It means all are not getting bright or dark at the same time. So phase sequence is opposite. This is the first thing, first conclusion you can outrightly draw. So if phase sequence is opposite, then D option is perfectly wrong. Now suppose this is going to be the frequency F1, this is going to be the frequency F2. F1 is the frequency of the existing system and F2 is the frequency of the incoming generator. Now there can be two possibilities. Either F2 is greater than F1 or F2 is less than F1. If F2 is greater than F1, then we are saying the incoming machine is faster. And when frequency is less, then we are saying the incoming machine is slower. Yes or no? Suppose we assume let F2 is greater than F1. What is going to happen if we take this assumption? Let us try to understand. If we draw the phases for the existing generator, suppose this is going to be R, this is going to be Y and this is going to be B. R, Y, B is going to be for the infinite bus. Then we have R dash, Y dash and B dash for the incoming generator that is next to be connected with the infinite bus. Now this R dash, Y dash, B dash, how we are going to draw? R is already there. If the incoming generator is faster than this, then suppose R dash is going to be somewhere here ahead, because we anti-clockwise we take the angle as positive. So R dash is leading R, because F2 we are assuming more than F1. It means machine is faster. If this is the case, then listen here. We have B dash here. Why B dash here? Why not Y dash? Because this side we are having R, after we are having Y. Because the incoming machine phase sequence is opposite. So we are writing B dash here. Then we have Y dash here. Now see how the bulbs are connected. He is saying lamp A is connected between R and R dash. So just connect it. Lamp A is connected between Let me choose a little interesting color. So you are connecting lamp LA between R and R dash. Those people who stammer, don't make fun of anybody, okay? Why opposite phase sequence? Because if it is the same phase sequence, then all the lamps are going to be dark and bright at the same time. Are you getting this? You have to draw the phasor diagram. From the phasor diagram, you can understand. From the phasor diagram, you can understand. Okay? Anyways, let us do this question, otherwise it is going to be missed. Then lamp B is going to be connected between Y and Y dash. Lamp B is connected between Y and Y dash. Then lamp C is connected between B and B dash. Lamp C is connected between B and B dash. Now please try to understand. More is the phase displacement between the two phasor. More is going to be the amount of EMF as a resultant. Okay? Are you getting that? So you can very easily understand that B is going to be the most bright. B is going to be the bright or dark first. After B, which lamp is going to be the next dark or bright? Please try to understand. R dash phasor is moving in this direction. R is moving in this direction. But its frequency is F2 and its frequency is F1, and F2 is greater than F1. It means the phase displacement between R and R dash is going to be increasing. Let us check. Lamp C is going to be the brightest one here. Lamp C is going to be the brightest one or the darkest one. Dark for the first time. From this diagram. Now R and R dash phase displacement is increasing. Now what is going to happen with this Y and Y dash? Because Y dash is moving with F2 speed and Y is moving with F1 speed, and F2 is greater than F1. So this phase displacement is decreasing. It means B is not the next lamp to be dark or bright. You can say after LC it is going to be LA, because A lamp is connected between R and R dash and its phase displacement is going to be increased. So this is LA, and the third remaining is now this LB. So this is going to be LC, LA, LB, or you can write LA, LB and LC, which is the given sequence of darkness, LA, LB, LC. So you can say the incoming machine is faster. C is going to be the correct option. Everybody just tell me. Are you able to follow this? Yes, everyone. All the candidates, please tell me. Important question, synchronizing procedure. You may get this type of interesting question. So be ready. Why C is brightest? Because of the angular displacement. Okay. The angular displacement, actually see what happens. Let me tell you. I think you have not attended the theory session. Anyways, you can write it. See here, suppose if there are two phasors. If there are two phasors, this is VA, okay, and this is VB, okay, or let me write like this. This is VB. So what is the phase displacement between them? 180 degree. So if I ask you this value VAB, that is VA minus VB. So it is going to be what? You have to reverse B and you have to add it. That is what is happening if you connect a lamp between R and R dash. So what is the voltage coming across? Listen, Vishnu. What is the voltage coming across the lamp A connected between R and R dash? It is R minus R dash voltage. Yes or no? More is the phase displacement. If you take the reverse, then it is going to be higher magnitude. I hope you are getting this. If you take the complete opposition, VAB, VA minus VB, you have to reverse it. Are you getting this, Mr. Vishwanathan? So when you draw the phasor diagram, the phases where phase displacement is maximum, that is going to be dark or bright for the first time. Listen, Baba, listen, Vishwanathan. You don't listen the complete story. Okay, please listen. What I have done, listen. First, I have drawn RYB phase, that is the infinite bus or the existing system. Then I have drawn R dash, B dash and Y dash, because opposite phase sequence, and R dash is going to be faster than R, or you can say Y dash is going to be faster than Y, or B dash is going to be faster than B. Now at this instant, I first check which phasor is going to have, which is connected to the bulb or lamp, having the maximum phase displacement. Okay, that maximum phase displacement is between B and B dash, which is connected to LC lamp. Now it is not stationary because phasors are rotating. R dash, Y dash, B dash, they are rotating with F2 frequency. R, Y, B, they are rotating with F1 frequency. So if you compare R and R dash, why we are comparing? Because lamp A is connected between them. So R dash is moving with F2 speed, R is moving with F1 speed, F2 is greater than F1, so their phase displacement is going to be increasing. But if you compare lamp B, Y and Y dash, Y dash is moving with F2 speed, Y is moving with F1 speed, F2 is more than F1, so this is going to be reduced. Not getting this. Okay, I hope you must be getting this now. Is it clear, everybody? Okay. So what is the correct answer? Phase sequence is opposite and the incoming machine frequency is faster. Let us see this question. Okay, this question I am giving you as part of your homework. This is about the parallel operation of alternators. Just do this question and give me the answer in the comment section. Okay. Otherwise, if you have any more doubts in electrical machines, you can join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena. If you have any more doubts, you can ask me. After this session, I will be providing the complete PPT of this session on this Telegram channel. So if you are interested, then you can join. Thank you so much for joining me live in the discussion. Best wishes from my side. Do not forget to join me again. Maybe next day, tomorrow or day after tomorrow, I will be available 6 p.m. and we will be starting transformers. After transformers, we will be discussing DC machines. Thank you so much. Take care. Thank you. Thank you, everybody.